What's up, geometry? Today we're going to be looking at lesson 5.5, proving triangles congruence by side 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 theorem, and also use the hypotenuse leg theorem. And we'll talk a little bit about what those mean. So still a continuation of triangle congruence. First thing we're going to look at is what is the SSS congruence theorem, and that just means if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. This is an obvious theorem. You just have to remember when you can use it and how to prove it. So as we can see here, we know that A matches B, A to B matches D to E, B to C matches E to F, and then C to A matches F to D. So then we can prove that ABC is congruent to DEF. So what we're going to do is look at this one, and we're going to figure out how can we write a proof, given the information, to prove that triangle KLM is congruent to NLM. So first we always want to start with our statements and our reasons. And the first statement is always your given. So KL is congruent to NL, and KM is congruent to NM. Okay. The next statement you might want to look at, I'm already given two congruent angles, but what about this third one right here? I know that LM is a shared side for both triangles, so what I can say is LM is congruent to LM, and that's just using the reflexive property. So now that I've proven all three matching sides are congruent, I can then say triangle KLM is congruent to triangle NLM by using the side 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 congruence theorem. Okay. The next one we have are deciding whether the congruence statement is true and then explaining your reasoning. So all of these are marked, and we just want to make sure how the congruence statement is set up if it is true. So it says DFG is congruent to HJK. Right now it looks like they are standing in the same order, but you just want to make sure however the order is written, those are the sides that should also be matching. So for instance, side DF, which is listed, the first two letters in that congruent statement, must match HJ, and they do. FG, which is here, must match JK. And then finally, DG here should match HK. This is one thing that you can do. It's called the stack, DFG and then HJK. Each of those letters has to correspond with the letter below it. So this one is yes, using the side, side, side. Okay, let's look at the next one. ACB matches CAD. So what we can do is either stack it, ACB, and then CAD. The one thing we want to pay attention to is we do have some varying numbers here. So for example, AB is equal to 3. So if I look at AB and is equaling to 3, according to my lines, AB should be equal to CD. And right now, if I look at CD, CD is equal to 4. So AB is not equaling to CD, so we would have to say no, AB does not match CD. The last one we have, it says QPT is congruent to RST. So again, lining up that stack, QPT and then RST. QP must match with RS. And right here, here's QP, here's RS. QT must match to RT, and they do. They both have one tick mark. And then the final one, PT must match ST, and they do. They both have that 3 tick mark one. So this third one is yes, due to side, side, side congruence theorem. In a right triangle, we have two things that we're going to look at first. The sides that are adjacent to the right angle are called legs. So adjacent just means right next to. So this is a leg, and this is a leg. And the side opposite the right angle, which is the longest side, this is called the hypotenuse. What we're going to do is use this information and then apply that to the hypotenuse leg congruence theorem. So this is another theorem we want to add to our list. If the hypotenuse and a leg of the right triangle are congruent to the hypotenuse and a leg of the second right triangle, then the two triangles are congruent. That's all you need to determine if they are congruent, because what a right angle does is it forces the hypotenuse to meet the legs at a certain point. So if one of the legs is congruent to another matching leg and the hypotenuse matches, then we know that the triangles are congruent. So really we're just looking at, do they have right angles? And do they have two matching sides, one being the hypotenuse and one being the leg? So what we're going to do here is talk about how can we write a proof here and to be able to prove that WYZ is congruent to XZY. The first thing we want to look at is our givens. WY is congruent to XZ. Something that might benefit us is separating these two triangles that are overlapped so we can clearly see what matches with what. So this one's W, this is Z, this is Y, and then this one up here is X, Y, Z. Okay, and it says WY is equal to XZ. So I'm going to go ahead and put some tick marks here. It also says WZ is perpendicular to ZY, which means this has a right angle. WZ perpendicular to ZY, and then XY is perpendicular to ZY, which is also going to create that right angle. Okay, so that picture, when you have overlapping shapes, again, it might be helpful to separate them just so you can visually see it a little bit better. So let's go ahead and start our proof with statements and reasons. Okay, the first one is always going to be our given, so let's take time to jot that down. All right, so here's my big given statement with the matching sides and the two perpendicular angles. Now what we want to know is how can I start going forward with proving that hypotenuse. What I do know is that angle WZY and angle XYZ are equal and 90 degrees. And that is due to the definition of perpendicular lines. Okay. We can also state that triangle WYZ and triangle XZY are right triangles. Again, I'm giving you every possible reason. You don't necessarily have to use all of these. These are just good starting points. So definition of right triangles. Okay, because I know these are right triangles, that also means at least the other sides are going to be equal. But I also wanted to show you this. If you look at your original shape, YZ is sharing the same thing as ZY. So we know, due to that diagram, ZY is equal to YZ or ZY, right? Okay, and that is using the reflexive property of congruence. So now that we know that, I'm going to mark that here. ZY, YZ, those are the same. Now I can use that theorem we just talked about. Triangle WYZ is congruent to triangle XZY using the hypotenuse leg congruence theorem. Okay. Last few examples, we're going to use this diagram here. Notice that the shapes are put together, so something we might want to do is think about how they could be separate. What we're going to do is redraw ABC and DCB side by side with corresponding parts in the same position. So what I'm going to do is I'm going to break these two triangles up. So I have ABC here, A, B, C, with one little tick mark. And then this side, I got B, C, D. Okay. It is obvious that we can see that the hypotenuse is equal, which is great for us. So again, with statements and reasonings, we want to prove that ABC is congruent to DCB. So one thing we know is that AC is congruent to BD. These are the hypotenuse. Triangle ABC, and not congruent yet, triangle DCB are right triangles. Okay, and then we can also say BC is equal to or congruent to CB using reflexive property of congruence. So we have now decided, and I'm going to mark that here just so we know that we've got enough information. Remember, for hypotenuse leg, we need the hypotenuse and the matching leg to be congruent. So now we can say triangle ABC is congruent to triangle DCB using the hypotenuse leg congruence theorem. Okay. Really, that's all that you needed to write here. If you decided to use any additional reasonings, you could have, but I'm not sure exactly what proof you could have done, especially with maybe AB and CD. We don't know if those are congruent, but what we can probably assume is that they are now that we know how these right triangles are setting up. Okay, that's going to conclude our notes today on lesson 5.5 using triangle congruence by side, side, side and the hypotenuse leg congruence theorem. Hopefully this video helped you a little bit. If it did at all, give it a thumbs up and tune in next time when we continue learning